Hello and welcome back. Our last speaker for the Science Data and Analytics track today is now based in Geneva, but he used to attend the Melbourne Python Users Group back when he lived here. It feels really good to be able to introduce him to the PyCon Australia audience. Lars Yencken is a Swedish-Australian engineering lead and data scientist, currently leading the tech team at Our World in Data, where he tries to wrangle the world datasets into shape and share insights into how we can make the world better using that data. However, most of the world datasets are scattered to the wind, or worse, stuck in Excel files of massive organizations, in tiny addendums to research papers in PDF format, and even in government tweets. Lars will take us for a dive into initiatives by Our World in Data to unlock this information. He'll share the joys and pains of data harmonization and ask how meta should data really be. So please give a warm virtual applause to Lars Yencken and to his talk, Systems of the World, Cataloging the World's Data for Great Good.
Thanks so much, Javier. And I should say, it's really fun to be able to join remotely, being an old Melbourner. So, as Javier mentioned, I'm from Our World in Data. I'm going to be talking to you about our efforts to catalog the world's data. A little bit about me. I'm born in Melbourne, but I'm also part Swedish. I've spent the last 5 or 6 years living in Stockholm in Sweden. I had a little boy there. We moved our little family to Geneva recently, and recently I've been working for Our World in Data, which is what I want to talk to you about today. Most of my kind of working career has been in data science or in leading engineering teams in the health space. But at Our World I should say, even the short experience so far at Our World in Data is quite different from these other data environments. And I thought this would be something people might enjoy. Today, you're going to learn a bit about Our World in Data and our mission. You're going to learn about what's involved in cataloging the world's data, and you'll learn how to find and query some of this data for yourself. So let's dive in. Our World in Data is a small non-profit. It's spun out of Oxford University by our founder, Max Rosa. And it's basically like a handful of researchers, a handful of data managers, and a handful of developers who are working together to try to shed some light on the world's big problems. And our mission is really to make the data on these really big problems understandable and accessible. We do that by writing articles that try to explain a lot of detail about these problems and make it accessible. And we write about poverty and inequality. We write about hunger, about disease, and about climate change, amongst a range of other topics. And now, one thing that really distinguishes the writing here, other than the kind of depth of research behind it, is that everything is backed up with these really rich interactive charts. So for example, here's a chart of COVID-19 vaccinations over time, and this chart, you can change the time frame you're interested in. You can add countries, so we can add Australia. And I know people are suffering in lockdown and trying to vaccinate as fast as possible in Australia. So but you can see that this curve is definitely on the rise. It also does interesting things, like if you click the time frame, you get an appropriate visualization like a bar chart. You can visualize things in maps. You get a lot of source information, and you can easily get to the underlying data too. In order to be able to write about these topics and have a lot of these rich charts, then actually we need a really solid data catalog behind them. So let's take a look at what's involved in building this data catalog. So we want to kind of help promote this evidence-based worldview on a really wide range of global issues. And if we want to do that, then we need really good data from a wide range of sources. If you've tried to pull data from different places, you will notice that all sources use their own special format. Generally speaking, I would say things are getting better year by year, but the world doesn't share a single format for exchanging data, and so what that means is that you have to deal with a huge amount of variety from different institutions and different researchers. You'll also find that every institution has its own view on the world, even if we just talk about countries. So institutions often report countries by name rather than by ISO code, and they also they use their own names. Sometimes it's kind of semi-political which name a country is used for a country. Countries have disputed borders, and different organizations decide what's in or out of a country. They also, based on the slice of global problems that they're looking at, then organizations also will pick like their own regions for the world. So we might think of the world as being neatly split up into different regions like Europe and Asia and North America and things like that. But actually the organizations cut the world up into special categories like low income countries, middle income countries, East Asia excluding China, South Asia excluding India, things like that. If you want to work with all this variety, you need to bring everything into this sort of common format, and then think about it from like a database perspective. If you want to be able to merge or compare things from different data sets, anything that you're going to join on, you need to harmonize. So that's especially things like countries, but it could also be things like diseases and the words they use for genders and things like that. Now, the COVID-19 dataset that we collect and republish, I mean, this is actually an extreme case of what our world in data goes through to collect data. Roll back a year, the world was just entering this pandemic. Governments are scrambling even to accurately, they're scrambling just to test, let alone report their testing. So the data reporting is only just beginning to come online for different countries, and the really big institutions like the World Health Organization that we might expect to collect and publish this data, it took them actually quite a long time to come to the table. So our World in Data team had a tricky pivot to decide on. Most of the big problems in the world, like child mortality, they don't change day by day. These big problems, the data sets on them, they're updated a few times a year or maybe even once a year. But COVID-19 data was coming in every single day. But the team basically leaned in to try and fill this gap. And that involved an immense amount of work. But that work enabled a lot of countries to be able to respond to, or to have better evidence to base their policy responses on. The one area, or just generally speaking, all this country reporting is getting better and better. The big organizations have come to the table. So a lot of the things that used to be hard are a lot easier, like testing and cases and deaths. But vaccinations is still a really interesting and difficult one. So our World in Data has a Nature paper where we discuss the assembly of a vaccination data set, but when it comes down to actually pulling it together, there's like all the usual suspects that you can imagine when you're trying to pull data in from wherever you can get it. And there's APIs, there's CSV and Excel, neither of which are that terrible. PDF was actually kind of prominent early on in the pandemic, like the World Health Organization was publishing data in PDF. And also numbers embedded in images and infographics. Actually, we still have them. But you might be surprised to realize that, in this data set, there's also daily figures that are only given by video, or daily figures that are posted to Facebook only, or daily figures that are only posted to Twitter. And there's still 12 countries that our Walden data fetches the daily figures from directly from Twitter. Interestingly, as well as like this difficulty getting access to data, there was one interesting case of like too much data. The government of Paraguay actually published vaccination status for every single citizen by name. So if you wanted to know how they're doing with vaccinations, you used to have to actually fetch this entire data set and then of all like people's names, stuff you don't want to know, but actually then roll that up into summary statistics. Thankfully now they do calculate those summary statistics, so we don't need to be fetching all of this very personal data on their citizens. So we've got data from these crazy sources and we're trying to bring it in, and what does it look like? What are we trying to bring it into? Our core data model is a tuple of 4 elements. An entity, which is often a country, but it could be something else, it could be a disease. A variable, a time point, which is either a year or a date, and a value. So for example, here we could read this tuple as Australia had a life expectancy in 1921 of 61 years. And if you're curious, the life expectancy today is more like 82, 83 years. So Australians are living 20 years longer than they used to 100 years ago. So when it came to our Walden data, I had, I'd been working in these commercial environments, doing data science, and there was a couple of things though that were really, really different about the data we were working with. In a commercial environment, let's say you're a successful company, you might have millions of customers, and for these customers, you probably have a lot of data, terabytes of data. It will be split in a few different categories. Some of it is like the direct stuff that is about your product. Some of it will be like marketing acquisition data. Some of it will be automatic machine logs, especially for debugging. So you have this massive data set, but a ton of it is machine generated, automatically captured. And probably it's only a few hundred variables actually, but a huge number of time points, a huge number of recordings. At our Walden data, there's not that many entities we care about. Like we're especially looking at countries. There's only a few hundred countries. You add in diseases and types of fish and different things. Still the number of entities is small. The number of time points we look at is small. But the data set has like over 100,000 different variables. And this is by far the most diverse data set that I've ever worked with. Every one of those variables is not machine captured, but is instead something that is like a research team has painstakingly put together, and people have had to go out and collect and estimate. So there's a huge value in this data set as well. It's a completely different shape to a commercial data set. So if we've got 100,000 variables, then we need more structure on them than that to even navigate our own data set. And in fact, we do have more structure. We organize these variables into datasets and datasets in namespaces. So for example, the one namespace might be the World Health Organization, and they release, for example, data. That one dataset they release is their Global Health Observatory, and so that might be a gigabyte or two, and that will have thousands of variables, and all of that will kind of come together. Something else that's very different compared to commercial data sets is the amount of metadata that we keep. And we keep that metadata for 2 reasons. One is for provenance, and the other one is for visualization. If I start with provenance, you might have been reading about these scandals in behavioral economics or social science recently, and this kind of dog ate my homework excuses that the data's missing, and I'm sorry. But actually, we know that in science, you should never have to take anyone's word for anything. You should be able to go back to that raw data at any time. It's exactly the same thing with our articles and with our charts. You should never have to take our word for anything at all. You should always be able to get straight back to You should be able to get the raw data from our chart in 2 clicks, and you should be able to get to the original source of that data as well in 2 clicks. And in that way, you can come to know that you can trust our charts because the data that we show you is really transparent about where it came from. So we keep we keep a lot of metadata around provenance at this level. The other side of metadata is around visualization. So think about it this way. When was the last time you just took a data frame and you plotted that data frame and you were like, yes, this is a chart I can show people. This is beautiful. It almost never happens. So you end up like changing axis labels and titles and adding all of this stuff. All of that stuff is actually information about the data that you're kind of adding later. So we have a lot of rich metadata about entities and variables that let us visualize them much more smoothly, so that we have to do more work when we get the data in, but we do much less work when we have to visualize that data. Just as an example there, if I take a look at life expectancy, here we can actually see that for some countries life expectancy goes all the way back to 1543. Things like the title of the chart is metadata around a variable. Things like the units in years. It might be really hard to see, but there's a little source description here that says where this data came from, and a note that explains what life expectancy at birth, what it sort of means. And one way you can think about it is that this is a chart that's designed to be shared like in a tweet out of context, and it should be pretty hard to misinterpret it, even if it's shared out of context. Other metadata that we keep is, of course, this provenance metadata. And in this case, for life expectancy, there's quite a detailed explanation of how this data comes together. And that's because it's stitched from several data sets. I'll just talk to you a little bit about our architecture that we use under the hood. So we keep an internal data catalog in MySQL, and this is our kind of source of truth for the world. At the moment, we publish over 1,000 data sets from that catalog. We republish them onto GitHub, but our goal actually in the coming year is to end up republishing more like 90% of that, nearly everything. The only things that we wouldn't republish would be things that are like data sets that are embargoed, or data sets that are that we're unable to share publicly. So our World in Data is actually a Jamstack site. It's statically rendered, the entire site. So that means that all the interactive charts you see are actually rendered in a kind of baking or compile process into the site that you see live, but this data set, this data catalog is never used when you use our live site. There's 3 channels for data to get into the data catalog. One of them is around COVID, because COVID is just such a special situation for the world. And we combine the automatic channels of reliable data that we know about, including Johns Hopkins University, perhaps the World Health Organization, along with some of the manual things that I showed you, pulling official data from tweets, Facebook posts, video, things like that. And we combine all of this in to make a reference COVID-19 dataset. And we publish that on GitHub. We have published a data explorer for that on our site. And you will, if you see global data being compared, if you'll see it in a newspaper, perhaps if you read The Age, the City Morning Herald, or something similar, you often see references to this particular data set. I also mentioned that there are these big institutions like the WHO, different departments of the United Nations. They go to immense effort to try to collect painstakingly information about global progress. So they usually release that a few times a year, and we do a process of bulk cleaning and uploading that anytime they do these releases. And this work is actually the work of 4 full-time people in a data team. Finally, if you are interested in, I should say, if you're looking at these big global problems, there are a lot of tiny facets to these problems. For example, there was new data that came out on diet affordability, which offered a kind of different perspective on global hunger. And this sort of research data set, actually our researchers themselves have a process, an admin that they can harmonize and bring this data in. So let me talk to you a little bit about getting your hands on this kind of global data so that you can actually, so that you can dig into these issues yourself. If there's a major global issue and you want to get your hands on that data, how can you do it? So, like everything else these days, search is still your friend. If you do a search, I would say, often you're hoping to get data from a big institution because you know that their data set is going to be pretty reliable, that they stake their credibility on it. But if you see our world in data in the search results, even if you don't care at all about our articles, it's still worth coming to us to try and get that data out. And I can explain to you a little bit why. Let's take a look at indoor air pollution. We can do a Google search for indoor air pollution. And it says that, this is dust, dirt, and gases in the air that could be harmful to you. You might think, wait, indoor air pollution, is this one of the world's big global problems? And it could be surprising to you to discover that, this kills 3.6 million people every year, which is 6 times more than all deaths from war, terror attacks, and murders combined. So it's definitely a major cause of death in the world. And well, let's look down and see what we find in these search results. We do see some stuff from the World Health Organization, and this is probably one channel that you can go and get data on this problem. But we also see an article here in Our World in Data. Now, even if you are not interested in the article, you can actually come down and look at the charts. Each chart is kind of representing a little small data set, and you can download this data directly if you want to. And here we see that outdoor and indoor air pollution together is the 4th highest risk factor for death in 2017. And maybe just a reminder for indoor air pollution, the reason indoor air pollution is a problem, it's for people who do not have good, clean energy sources to feed, or to cook food and to heat their homes. And that means they have to burn solid fuels, and then you have this bad smoky environment in the home. Actually, it affects 3 billion people worldwide. We can see that especially it affects sub-Saharan Africa, East Asia, and you might not be aware, but nearly 11% of our neighbors in Papua New Guinea die because of indoor air pollution. So it's actually a reasonably significant problem. Again, to get the data on this, it's very simple, just to click and get a CSV, and the CSV is easy to work with and to use. Suppose you do this search and you don't for whatever reason you come dry. You don't find an article from us that lets you quickly get to a chart and get to a data set, or you get to an international institution but you end up chasing your tail in circles because they don't make the data super easy to get. So then there's 2 really good open data catalogs published on GitHub. One of them is from us at Our World in Data, our OWID datasets catalog. The other one is from Gapminder. And Gapminder you might especially know from the late Hans Rosling that used to do really excellent TED Talks. Their mission is to combat devastating ignorance in the world. And they are also trying to collect and republish global progress data in a really nice way. Both of these data sets, both us and Gapminder, we actually publish in a format called frictionless data. Now, I had never come across frictionless data until recently, so this was kind of news to me. It's interesting when you've worked in data science for ages, but you haven't had a chance to actually, well, you discover a format that people are using that you've never used before. I mentioned all sorts of like weird ways of getting data in. Like, well, I mentioned we have to check videos and tweets and Facebook. CSVs are definitely not the worst format. On the other hand, when you think about the last time you used a CSV file to do some serious work, first you load it in, super easy, but then the first thing you have to do is fix all the types. And this is a problem with CSV, that it's kind of lossy with respect to types or the schema. If you save your CSV file, you load it back into a data frame, it's not going to be the same data frame. So this is one problem. CSVs don't have a schema. The other problem with CSVs is that they don't have any room for the type of metadata I described to you before. Like, where did this column come from? What does it mean? What units are it in? Things like that. I think of the frictionless format as being CSVs without shame. So you've got CSV files. There's some nice things about them. Like, you can really easily look at them as a human, but they lack this kind of machine readability, and they lack this metadata. So if you basically add a JSON sidecar file, datapackage.json, that includes these things, you've more or less got this frictionless format. Yeah, so maybe we can take a look at that actually. So if I go to our, and I'm in GitHub, I'm in Our World in Data and the Our World in Data datasets. You can, we can click straight into datasets, and we see that, well, there's over 1,000 datasets here covering all sorts of things: work and leisure, access to electricity, literacy, tuberculosis. Let's take a look at the affordability of diets. Again, a nice thing about frictionless format is that the CSV is still there. You can still just go and look at it. And here we are, we're able to see various costs of eating enough calories versus the sort of diet that your body needs. But you can also look in the datapackage.json file, and here then you would see a lot of this metadata. Where did the data come from? You see a schema, and including descriptions for different columns, and also some of this display data, like the cost of a calorie-sufficient diet. The short unit here is, if we don't have space, we call it $1. But if we've got more space, we say this is actually technically a 2017 US dollar per day. There's a frictionless package in Python that makes it super easily to load in this data and to get to both the metadata and the data frame out. And so I recommend that if you're interested in that format. Just some thoughts to close here. So at Our World in Data, we talk about massive global problems, and the world has really big problems. And on the other hand, when you look at the news is also kind of giving you all of these problems, showing you all these things that are wrong with the world every single day. And you combine these things, and it's really easy for people to get cynical and to feel like there's not much worth in putting their efforts into trying to make the world better. And surveys of young people show that a lot of them feel like the world is in decline. At Our World in Data, we think that the really big picture that we should be considering is both the massive global challenges and the massive global achievements that we've had. If we talk about some of these achievements, they're things like moving from a world where nearly everyone lived in extreme poverty 200 years ago to a world where we've been able to close and close and close this gap, and we can really foresee that we'll end extreme poverty you know, likely in the next 50 years. We live in a world where more than 40% of children used to die before the age of 5. And we've been able to really, really drastically cut child mortality, especially in the last 100 years. So that more and like even this gap that's still left, it's still unacceptable, but yet we're doing so much better now than we were before. More and more people can read, get access to ideas, navigate their local communities better. And this corresponds with a massive increase in the global level of education, something that's projected to continue well through the end of the century. And people are also living in greater and greater political freedom than they have in the past. And especially the last 100 years, we see the end to the colonial era. So, you can understand someone writing an article like this has been the best year ever. Except, the moment they wrote it, a global pandemic was beginning. And I know you're all in lockdown, so you'll be like, Lars, this is not the best year ever. But I really believe that if we put our energies into these massive global problems, this pandemic, we're going to see our way through it. On the other side, soon I think we'll be able to say again that each year will have been the best year ever. And yeah, that's me. Thank you.
Thank you, Lars. This has been Sovereign Talk, and people on the back channels were asking loads of questions. We have time for a couple.
Sure.
So the first one is the most voted by the audience. How does a world of data relate to fair data principles? And what would make your work easier in that regard?
If there is a kind of technical concept of fair data principles, then unfortunately it's still something for me to learn. But I would say there's two things that would make our work a lot easier. One would be a really nice standardized format for that big institutions and researchers both publish in. That would be super nice. Maybe on the other hand, if I instead of talking about what will make our work easier, if I just talk a little bit about a fairness angle, our world in data now gets quite a lot of traffic about a lot of issues. And when I was a researcher, when I collected data, I was always terrified about sharing that data because I was sure that someone else would scoop me, they would publish something, they would find something amazing in my data that I didn't. Our world in data is we try and be super, super good about any time we grab data from researchers. Well, firstly, we talk to the researchers, but we also make sure to try and direct all credit and we direct people back to the researchers because that's definitely what's needed to get more people to be willing to share their data. And I think, it's just like the more people who are able and willing to share what they have, I think the better it is for the community.
People were asking also, the visualizations look great. What tools do the team use?
We developed an in-house tool, which we call Grapher, and I've actually been doing some work to try and port that to a nice Python interface that you could use in a Jupyter notebook. In some ways, it felt, you could say, well, there's so many good data visualization tools, it's crazy to write your own. Why would the team do that? I think a big piece of this is the need to support all of this metadata. Like with the right metadata, the charting of these issues should become really easy. And you should be able to get a really rich interactive chart in just like, just a few lines of code. But the existing charting tools, they really require you to specify everything about a chart. So that's a massive difference in the kind of open source tools that are out there today and the tool we're using. I should mention that Grapher is open source, but I would say it's not split out into a code base in a nice enough way for external contributions at the moment.
Thank you. We have many more good questions, and I invite you to go on Venuless and interact directly with the audience if you have a moment. And I also want to thank you. Thank you, Lars Yencken, for being the closing speaker at the PyCon 2021 Data Science and Analytics track.
Thanks so much, everyone. Thanks, Javier.
Bye. And for everyone who's still following we thank you also for your attention, and we would like to give you a small goodbye in 10 minutes from now at 5:45 Melbourne time. See you then.